Good morning, Year 6, and welcome to a week of shapes. And a new face for you, Mrs. Pratt here, and we're going to be thinking about 2D and 3D shapes, about translation, rotation, and the symmetry of shapes throughout this week. But today's session is all about the translation of shapes, and we're going to exploring this vocabulary and what it means, and what we need to do to translate shapes successfully and give directions to others so they can also translate shapes. So please get your piece of paper ready and get your resources that you need. And today's date is the 22nd of February 2021. And our Can I title is Can I describe the translation of shapes and translate shapes using a given direction? So for today's learning, you're going to be successful if you can use the directional language left, right, up and down. And for an extension to this, you will be referring to your previous knowledge of coordinates and grids of the X and Y axis, which will give you another way in which you can explain how a shape has been translated, a more grown up, I guess, and a more an extension to the initial directional language that you are going to be using. You will also need a copy of today's sheets. We're going to be using these, so make sure you've done your arithmetic warm-up before you start the main bit of our learning. There are various tasks that you need to do today, and I'll talk through the various options for both green and blue group to both extend and support you with your knowledge of shape translation. So when you're ready, pause the video if need be, and we'll get straight on with our session today. So first question really should be, what is a translation? So a translation is just a slide, and you must be specific about how far along or back and how far up or down this slide has taken. So it's about a movement of a shape from one place to another, but the shape itself isn't stretched, isn't squashed, isn't turned, or it isn't reflected. There's some images there to help you know what this shape isn't. As you can see from the example here and this hand here, it's about moving that shape but not changing the shape. So we've got shape A, shape B, exactly the same look of the shape, they have just moved in position on the grid. So it's important that you are not changing the shape, and if your shape does change when you look at it, when you've translated it, you haven't translated the shape successfully, and you'll need to go back and have a rethink about plotting the vertices on that shape in its translated form. And we'll talk a bit more about this throughout this input. So keep referring back to the fact that the translation is a slide. Okay, so let's have a look at this shape, and we'll talk about how you describe the translation of a shape using directional language. And also we'll extend you into how to use the language of as a vector to describe the translation of a shape. This will be something that will be a real extension to each of your tasks today, so I don't need you to worry about this. I would rather you focused in on the directional language, but obviously I'll touch upon describing translation as a vector also. So first thing to do, obviously, as we all do with all questions, is look at what it's asking us to do. So it says here, how has the light blue shape, so we're talking about this light blue shape here, been translated into the dark blue shape? So I've underlined the information that I need to be able to access this question. And what I've also noticed about the light blue shape and the dark blue shape is they have one of the vertices have already been labelled with the letter A. It's quite a useful technique that you will need to use for this session, and that's about labelling each of the vertices on the shape to check that you are following the directions correctly and to check that your shape is the translated version of the first. So the first thing we're going to do is have a look at this point here, and we might also want to be thinking about the other parts of the shape as well, so I'm going to label those. So this vertices here I'm going to label B, and the final one over here I'm going to label C, so that I can know that I am going to be translating this shape from the light blue to the dark blue. I'm going to be sliding it, moving it, but not changing its the look of it. Okay, same thing happens over here. So I just label this where I hope it will translate to if I give the correct instructions. So we start off with our first point here, the point A, and I'm going to be having a look at where it has travelled to get to the dark blue triangle shape here, dark blue right angle triangle. So we're going to go across here, 1, 2. You can see now I'm in line with the shape that I'm translating to, and then I'm going to go from this point, 1, 2, down. So my instructions for translating this is 2 to the right and 2 down. So I'm using the language of right and down as my directional language. Okay, so I've written that down there, 2 right, 2 down. That's the instruction I'm going to follow. Now I want to check that this is working for the other vertices on the shape, so that my shape is exactly as it should be translated. So I'm going to go to my next vertices here, B, and I'm going to follow the exact same instructions, 1, 2 to the right and 2 down, and then I should get to my point B. I could repeat this with point C to check that I have translated it following the correct instructional language. So for most of you, you'll be using the language of right and left and up and down to describe how a shape has been translated. But the most important key to this is that you identify the vertices on the shape that you are starting with, and where that, how that links to the shape you're translating to, whether you're drawing this shape for yourself or it's a shape that's already there. And if you look on your sheet, you will see that the first, for task 1, it's talking about how shape A has been translated into shape B, so that you will be talking about how has the vertices, the points on shape A, been translated to the points on B. And if you just take one and describe it, you will know how it has been translated, and you can check it with a further 1 or 2, possibly 3 vertices on your shape. Okay, so the next bit is a little bit more complicated. Please don't worry about this bit, but we can also describe the translation of shapes as a vector. Now, vectors refer to our x and our y axis. So if we're looking first, when we're looking at a vector, so I'll just put the brackets would normally go around this. You can see here. So what you can see is that we refer to the x-axis first. So if we go to, we use point C as a point of reference here. So if we're going to go for the x-axis now, it says 2 here. Now it doesn't say positive 2, but we don't normally put a positive sign in front of a number. We will put a negative one. So we can assume this is a positive 2, and we're going to be going 2 positive, 2 increase by 2 along the x-axis. So it's going to get bigger along the x-axis. So here's a point C. We're going to go 1, 2. In fact, what we are doing is we're following exactly the same instructions as up here. We're going 2 to the right, but we're going to go 2 along the x-axis positively. And then we're going to be going for our second coordinate point here. We're going to be doing a -2 on our y-axis, our vertical axis. So we're decreasing by -2. We're going towards the minus numbers if you think about it in temperature wise, so you can think about how we're describing the translation position. So here we go, 1, 2. So we've done now -2. We've decreased our number, if you like. We started at 3 and we've gone back 2, we've got to 1. Okay, and there we find point C. So actually, this is a description as a vector of the translation that has happened between the light blue right angle triangle and the dark blue right angle triangle. And as you can see, the second Y instruction there is our same as our second directional language, 2 down, which you're going -2. So that is just an additional extension to your knowledge on the translation of shapes, but please just focus on this directional language if that at all confuses you. So here we have two shapes. I'm going to underline some of the what question terms are, so that you can have a think about how this shape has been translated, and you can pause the video and have a go for yourself. So how has the red shape, so a red shape is our starting point, and luckily this one has been carefully labelled, helpfully labelled, sorry, with the points A, B and C. And how has it been translated to the blue shape? So our second shape that is our translated form is this blue one here. And you can see the points A, B and C also being labelled, the vertices on that triangle. So your job is to describe how it has moved, how it has slid from this position to this. It obviously hasn't changed in any way, but it has moved on the grid. So talk of it as a direction, and if you want to challenge yourself, you can think about how would you explain it as a vector. Remember, the key for this is take one point and look at what has happened to translate from that point to its similar point on the second translated shape. Pause the video, have a go. Okay, so hopefully you will have seen that if we take point A, I will start with a green, for example. I have got point A here, and I have translated it by going to the left 1, 2, 3, 4, 5, and then I have translated that point up by 1, 2, 3. So my directional language is 5 to the left and 3 up. And if I follow that for point B, I will hopefully find that that language will continue to give me the way that the shape has been translated. So I'll change the colour on that one. So if we look at B here, so if I follow the same language, 1, 2, 3, 4, 5, and up 3, 1, 2, 3. My translated B is exactly in the right place. So I can see that I have got a translation of the shape, and I know the directions that I needed to give to translate this shape, red shape, to the blue. Now, as before, I've left C for you need to go through the vector as a vector, but obviously please use directional language if this is confusing for you. So we've got here, oops, sorry, I'm trying to do this with a mouse. So let's look at this with a different color. I think I'll go with, let's go with orange. Hopefully that showed for you. So I've got C here. Now, just as before, we've got our x-axis saying -5. So this is our horizontal axis here, and it's asking us to go -5. So we're making the numbers smaller, like temperature gauge. You can actually see we're already getting in towards the minus numbers anyway, if we're looking at the axis, but we're going almost backwards. We're going to the left. We're looking back at our directional language to help us, and it's the x-axis we talk about first. So -5, 1, 2, 3, 4, 5. And then it says our y-axis, our vertical axis is 3, a positive 3. So we're going to be increasing it by 3. So we're going to be going up by 3, looking back at our directional language to help us with our y-axis. So we're going to go 1, 2, 3. And there we have the vertices C being translated successfully. So that's the instructions that we would be giving, directional language instructions, in order to translate this shape, because it works for all of the vertices, and therefore the whole shape has been translated following those directions. Okay, year 6, for task 4, you are going to be asked to actually follow some directions to translate its shape to its new position. So we're just going to go through that little part on the video so you can see how that works. So as you can see here, I have got a X and Y axis with a shape already drawn on the grid, and the positions have already been marked, and it's really, really important to follow those points that you need to put on your new translated shape once you've followed the instructions. So it's going to be a really key part of this session that you plot the new points first, as it says here. So plot the new positions first and then draw the shape. So let's get started with this one. So the instructions say that we need to translate this shape, and we know what translation means by now, but we need to translate this shape by 4 to the right and 2 up. So what I suggest you do is that you might want to use different colours for this so that you can really see the different vertices that you are translating. So if we start with A here, and with point A, we're going to take this shape, this vertices 4 to the right. So 1, oops, sorry, 2, 3, and 4. And then it says 2 up, 1, 2. And so this is then going to become our new point A, our new translated shape. With a different colour so you can just see how clearly. We've got our vertices at point B here. We're following exactly the same translation instructions from the top here. So we're going to go 4 to the right, 1, 2, 3, 4, and 2 up, 1, 2. And there we have our point B. Now I know I'm on the right track with point B because I knew that there was a straight line between A and B, and the same I can see already forming here on my translated shape. And then I've got my point C, in a different colour. There we go. It's following the same instructions as above, the directional instructions. So I've got 1, 2, 3, and 4, and going up to 1, 2, and there marks my point C. And once I've got all my vertices plotted on, then I can start drawing my shape and forming my newly formed translated shape, so I can see what it looks like when it's following the instructions and being translated. So there you can see my new shape being drawn, follow the translation instructions up here. And you might want to be thinking about, oh, what would these instructions look like if I was expressing them as a vector? And remember, we talk about our x-axis first and then our y-axis. So have a think about that as a little extension thought for you. Okay, so following on, it should have looked like that, which is really good, it does. So here, a little bit more tricky, we've actually been given not the directions as directional language, but the directions as a vector. But we've been asked to do the very same thing. So we've been still asked to plot the position of the new shape onto the grid and then draw between those vertices to form its newly formed translated shape. So for some of you, you might not get onto this where you've got talking about vector instructions to help you with how you might translate the shape. But for those who are ready, we've got to remember our x-axis and our y-axis noted down. So we've got our x-axis first and then our y-axis. Now this shape is called shape A, but it hasn't got its vertices plotted. So the very first thing I'm going to do is I'm going to label all the vertices. I've got A there. It'll come up very clearly. It's blue, sorry, I should have picked a different colour. Got B, and let's go for red for this one. We've got C. Okay, so we're following these instructions to help us, and we'll start off with this first one. So this says -2, and it's referring to our x-axis. So this is our x-axis, our horizontal axis, and we're going to go along -2. In fact, if we're talking about directional language, we would be going 2 to the left. Okay, and then we look at our second instructions here on our y-axis, our vertical axis, and we're going to be going -3. So here we go, 1, 2, make sure it's accurate, and 3. So our new position for A is here. You can see that's the new translated position following this translation instruction expressed as a vector. So I'm going to continue with that. So I've got my point, my vertices B here, my point B, and I'm going to follow the instructions. So I've got my X first, I'm going to do B -2. So we're going to the left, -2. And then we're going down, -3. So we're decreasing the number by 3. So we're going to go 1, 2, 3. And then we can plot on point B. Okay. And then finally, we've got our final point of our triangle there. So we're going to be following the same instructions to translate the shape, because it's all the same for every vertices. And we're going to go -2, 1, 2, our x-axis first, going backwards, we're going to the left, we're decreasing by -2, and then we're going to go down -3, 1, 2, and 3. So our third point is there, so that's point C. Okay, and then once we've got our positions plotted onto our grid, then we can go and form our shape, draw our shape using our ruler. Try my best now, and then make sure I got this right. Just about there. So then you can see this is our newly translated shape following these vector instructions. And obviously you could have been using directional language which would be 2 left, 3 down. Okay, so there's where both instructions can be used to form a newly formed shape. And that's what it would look like without all the lines on it. Okay, so today's task. So I'm just going to go through some of the things that green group and blue group might be doing following your arithmetic practice. So task 1 is very doable for both green and blue group. And the difference would be that if you're in green group, I only need you to explain how shape A has been translated to shape B with the use of directional language up, down, left and right. If you're in blue group or you want to challenge yourself, then you also need to tell me how it would look as a vector. So saying the x-axis, how it is moved, and then the y-axis. Look back at my examples for that. So directional language is the key for this task 1, how it's gone from A to B, but also you can be expressing it as a vector. Task 2 just gets a bit more, it's exactly the same, but it's just a bit more complicated shape. So it's a bit harder to perhaps see how it has been translated. But that is doable for the majority of you. If you have struggled with task 1, or you've been doing task 1, questions 1 and 2 and really flying with them, then I would go on to task 2 to challenge yourself. If you are really struggling with task 1, I'd just get task 1 done and not worry so much about the more challenging shapes in task 2. Task 3, however, is something both blue and green group can do. This is looking at the spotting mistakes, or true and false, about what has happened to the shapes as they've been translated, and the directional language is used in there, so we haven't got any vectors in there. So I think all of you can attempt the 2 tasks in task 3. Task 4 starts off fairly straightforward. It gives you directional language of the way in which you are, where the position for you to draw the newly translated shape. And I think the first 2 of task 4 are doable for all groups, green and blue. As you get further on translating into shapes, it gives you it as a vector, so you might want to be steering away from those if you find that a bit challenging, but you can certainly start task 4, everyone. As it goes on to task 5, it just becomes a little bit more complex with more complex shapes, and it looks like, yeah, it's in the 4 quadrants as well. So as always, the answers will be found on the sheet, so you can check them through and check you're on the right track, and also check whether you need to extend yourself by moving more swiftly on from task 1 into task 2, or you need more practice of the task one's activities before moving on to perhaps just going to task 3. Okay, so hopefully that will explain to you what you need to do for today's session, and look forward to seeing you tomorrow so that we can explore a little bit more about the properties of shapes. Bye for now.